We will be looking into the subject called matter. But before we start, please subscribe to this channel to keep ahead with other educational videos from us at Book Flow. You're loved! And now we begin with the definition of matter. Matter is anything that has mass and occupies space. This means that for something to be called matter, it must be able to be weighed and must take up some volume. Everything around us is made of matter. Examples include air, water, stones, books, plants, animals, and even human beings. Matter exists in different forms and states, but they all share these basic properties. Matter can be seen or unseen. For example, solids like chairs and tables can be seen and touched, while gases like air cannot be seen but can be felt. Matter can change from one form to another through physical or chemical changes, but it cannot be destroyed completely. This idea supports the law of conservation of mass. Matter is made up of tiny particles called atoms, molecules, or ions. These particles are constantly moving and interacting with one another. The behavior of matter depends on how these particles are arranged and how strongly they attract each other. In chemistry, the study of matter helps us understand how substances behave, react, and change under different conditions. Understanding matter is very important because it forms the foundation of all scientific studies. Now we look into particle nature of matter. The particulate nature of matter simply states that all matter is made up of very tiny particles which are too small to be seen with the naked eye. These particles may be atoms, molecules, or ions depending on the substance. Even though matter appears continuous to our eyes, it is actually made up of discrete particles. These particles are always in constant motion. The movement of particles increases when matter is heated and decreases when it is cooled. This explains why substances expand when heated and contract when cooled. The particles also attract one another with forces of attraction known as intermolecular forces. There are spaces between the particles of matter, and these spaces differ depending on the state of matter. For example, particles in solids are closely packed, while particles in gases are far apart. Evidence of the particulate nature of matter includes diffusion, Brownian motion, and the compressibility of gases. For example, when perfume is sprayed in a room, its smell spreads because the particles move freely through air. The particulate nature of matter helps explain many physical properties of substances such as density, pressure, and states of matter. Don't forget, just acting as a reminder to ask questions where necessary and you'd be sorted out. We forge ahead. Intermolecular forces. Intermolecular forces are the forces of attraction between particles of matter, such as molecules or atoms. These forces hold the particles together and determine whether a substance exists as a solid, liquid, or gas. Intermolecular forces are weaker than the forces that hold atoms together within a molecule. There are different types of intermolecular forces, but they all act to keep particles close to one another. In solids, these forces are very strong, causing particles to be tightly packed and fixed in position. In liquids, the forces are moderate, allowing particles to move past one another. In gases, intermolecular forces are very weak, so particles move freely and are far apart. Intermolecular forces affect physical properties such as boiling point, melting point, viscosity, and surface tension. Substances with strong intermolecular forces usually have high boiling points because more energy is needed to separate the particles. Heating a substance weakens intermolecular forces, which can cause a change of state. Cooling strengthens these forces. Understanding intermolecular forces helps explain why substances behave differently under various conditions. We dive into interparticle spaces. Interparticle spaces are the gaps that exist between the particles of matter. These spaces are not empty but are simply the distances separating one particle from another. The size of interparticle spaces varies depending on the state of matter. In solids, interparticle spaces are very small because the particles are closely packed together. This makes solids rigid and difficult to compress. In liquids, the spaces are larger than in solids, allowing particles to move and slide over one another. This is why liquids can flow and take the shape of their container. In gases, interparticle spaces are very large. The particles are far apart and move freely in all directions. This explains why gases are easily compressible and can expand to fill any container. Interparticle spaces increase when matter is heated because the particles gain energy and move further apart. When matter is cooled, these spaces decrease as particles lose energy and move closer together. The concept of interparticle spaces helps explain properties such as diffusion, compressibility, and changes of state of matter. States of matter. Matter exists in three main states, which are solid, liquid, and gas. These states depend on the arrangement, movement, and attraction between the particles. In the solid state, particles are closely packed and held together by strong intermolecular forces. The particles vibrate about fixed positions but cannot move freely. As a result, solids have a definite shape and volume. Examples include stones, metals, and ice. In the liquid state, particles are less closely packed and the forces of attraction are weaker than in solids. The particles can move past one another, allowing liquids to flow. Liquids have a definite volume but no definite shape, they take the shape of their container. Examples include water, oil, and kerosene. In the gaseous state, particles are far apart and intermolecular forces are very weak. The particles move freely and rapidly in all directions. Gases have neither a definite shape nor a definite volume and can be easily compressed. Examples include air, oxygen, and carbon dioxide. Changes in temperature and pressure can cause matter to change from one state to another. Understanding the states of matter helps explain many physical behaviors of substances. Now the kinetic particle theory of matter. The kinetic particle theory states that all matter is made up of tiny particles that are in constant random motion. The particles possess kinetic energy, which increases with temperature. The theory explains the behavior of solids, liquids, and gases based on particle movement, spacing, and forces of attraction between the particles. Change of state. A change of state occurs when matter changes from one physical form to another without changing its chemical composition. This usually happens due to changes in temperature or pressure. When a solid changes into a liquid, the process is called melting. For example, ice melts into water when heated. The reverse process, where a liquid changes into a solid, is called freezing. The change of a liquid into a gas is called evaporation or boiling. Evaporation occurs at any temperature from the surface of a liquid, while boiling occurs at a fixed temperature called the boiling point. The change of gas back into liquid is known as condensation. A solid can also change directly into gas without passing through the liquid state. This process is called sublimation, while the reverse is called deposition. During a change of state, energy is either absorbed or released. When heat is absorbed, particles gain energy and move further apart. When heat is released, particles lose energy and move closer together. Change of state is a physical change because no new substance is formed. Atomic structure and composition. Atoms are the smallest particles of an element that can take part in chemical reactions. Each atom is made up of three main subatomic particles: protons, neutrons, and electrons. Protons are positively charged particles found in the nucleus of an atom. Neutrons have no charge and are also found in the nucleus. Electrons are negatively charged particles that move around the nucleus in shells or energy levels. The nucleus is the central part of the atom and contains protons and neutrons. It is dense and positively charged. Electrons occupy spaces around the nucleus and are responsible for chemical reactions. The atomic number of an element is the number of protons in its atom. It determines the identity of the element. The mass number is the sum of protons and neutrons in the nucleus. Atoms combine with one another to form molecules or compounds. The arrangement of electrons determines how atoms bond and react chemically. Understanding atomic structure helps explain the behavior of elements and compounds in chemical reactions. And now, we dive into gas pressure. Gas pressure is the force exerted by gas particles on the walls of their container. Gas particles are in constant random motion and collide with one another and with the walls of the container. These collisions produce pressure. The pressure of a gas depends on several factors, including temperature, volume, and the number of gas particles. When the temperature of a gas increases, the particles move faster and collide more frequently with the container walls, causing the pressure to increase. Reducing the volume of a gas increases pressure because the particles collide with the walls more often. This explains why gases are compressible. Increasing the number of gas particles in a container also increases pressure due to more frequent collisions. Gas pressure is measured using instruments such as barometers and manometers. Common units of gas pressure include Pascal (PA), atmosphere (atm), and millimeter of mercury (mmHg). Gas pressure plays an important role in everyday life, such as breathing, inflation of tires, and weather changes. Understanding gas pressure helps explain the behavior of gases under different conditions. What is not matter? Not everything in the universe is matter. Phenomena that lack mass and volume are considered forms of energy, such as light, sound, heat, and thoughts. And we bring the matter to a halt at the moment. Please, don't forget to subscribe, and if there's need for more explanation of what matter is all about, or you need question based on whatever as regards to matter, we're available to help. Please speak up in the comment section. Goodbye, see you in the next one, happy learning and cheers.